rotational kinetic energy. In this video, we are going to expand the introduction of the kinetic energy. Up till now, the kinetic energy Ke was introduced to equal 1/2 mv squared. In some motions, it is very important to be more specific in the description of the kinetic energy, and for that reason, we are going to call this form of kinetic energy translational kinetic energy. The reason we called it translational kinetic energy is because the center of mass of the moving object is translating in space from one point to another. Now, how about if the object is in the form of a disk or a flywheel that is spinning about a fixed axle? Clearly the object is in motion and must carry kinetic energy. This kinetic energy is known as the rotational kinetic energy, and its mathematical expression is given by the following relationship. Ke rotational equals 1/2 I, the moment of inertia, times omega squared, the angular speed squared. Notice the similarities between the two forms. The translational kinetic energy depends upon the linear inertia, known as the mass, and the rotational kinetic energy depends upon the rotational inertia, which is known as the moment of inertia. Notice also that the translational kinetic energy depends upon the square of the linear speed v, and the rotational kinetic energy depends upon the square of the angular speed omega. Finally, how about if the object is rolling with respect of a given surface? Clearly, the object is spinning about its own axis of rotation, while its center of mass is translating. In this case, the object carries both forms of kinetic energy. The total kinetic energy is going to equal the translational kinetic energy 1/2 mv squared plus the rotational kinetic energy 1/2 I omega squared.